Division of a monomial by another monomial. Mono means single. So algebraic expression having a single term is called as a monomial. Here this is division of a monomial by a monomial. This is also another example of same type of division. Before we continue with this division, let us first revise the laws of exponents. What we have, a raised to m upon a raised to n is equal to a raised to m minus n. These are the variables with some power. Now these bases are same, division of numbers, and that is equivalent to, or that is equal to, difference of the powers with the same base. Now for this division, minus 20x raised to 4 divided by 10x raised to 2. In this division, we will divide constants and variables separately. For constant division, minus 20 divided by 10. If we first divide both these numbers by 10, then we can cancel this 0, and minus 2 divided by 1 is minus 2. In division of two numbers, if the signs are different, answer is negative. And to perform this division, x raised to 4 divided by x raised to 2, that is equal to x raised to 4 minus 2. So this is x raised to 2. 4 minus 2 is 2. Similarly, 7x square y square z square divided by 14xy z. Let us divide these numbers again in two parts, division of constants and division of variables. These are multiple of 7. 7 version 7, 7 2s are 14. So constant division is 1 by 2. This x square upon x, no power is here, means the power is 1. So by using this law, this simplifies to x raised to 2 minus 1, that is x raised to 1. If the power is not written, that power is 1. Also, y square upon y means y raised to 1 is y raised to 2 minus 1, that is y raised to 1, that can be written as y. And same with z, z square upon z is equal to z raised to 2 minus 1, that is z raised to 1, which can be written as z. So this is how we can divide monomial by another monomial. Next topic is the division of a polynomial by a monomial. So your dividend can have more than one term. Example is 4y cube plus 5y square plus 6y divided by 2y. Now there are two methods to complete this division. As we observe, every term in numerator has y. So let us take that y common. Now this 4y cube is actually 4 into y, 5y square is 5 into y, and the last term is 6 into y. So each one has one y in common, or each one has at least one y. So we can take this y common. After taking this y common, we will write these terms without y inside the bracket. So here we have 4y square. This y we have written combinedly outside the bracket. 4y square plus 5y plus 6 divided by 2y. We can divide this y, and now our answer is 4y square plus 5y plus 6 divided by 2. Now if we want, we can take 2 common from the terms in numerator. This 4 can be written as 2 into 2, so we can take 2 common. Now this 5 is not even number, but still as we want to take this 2 common, we write this as 5 upon 2. So we are multiplying by 2 outside the bracket and dividing by 2 inside the bracket. That will keep the value of term same. Plus 6 but after taking 2 common it becomes 3. Now we cannot take variable common because this last 6 has no y, so we can divide this 2 and our answer is 2y square plus 5 by 2 y plus 3. This is method 1. In second method, instead of taking common, we separate these terms and then it becomes a division of monomial by monomial. 4y cube upon 2y plus 5y square upon 2y plus 6y upon 2y. Now each term is a division of monomial by monomial. So divide constants and variables separately. 4 upon 2 is 2. Y cube upon y raised to 1 is y raised to 3 minus 1, that is y square. Now 5 is not exact multiple of 2, so we write this as 5 upon 2 and this is 2 minus 1, that is 1, which can be written as y. Now here we can cancel this y and 6 upon 3 is 6 upon 2 is 3. Now when we have y upon y, both of these numbers have their power as 1 and we write this as y raised to 1 minus 1, that is y raised to 0. Any number other than 0 raised to 0 is 1. So this division is 1 and 6 upon 2. This division is 3. Answer is same, but the method is different. Polynomial by polynomial. For this division, your divisor will have more than one term. It will not be a monomial. 7x square plus 14x upon x plus 2. If we observe our numerator, we find that 7x can be taken common because 7 and x both are there in 7x square and 14x. 7x square is actually 7 into x and 14 is 7 into 2 into x. Now we are going to write this 7 into x common outside the bracket. So in bracket we have x plus 2 divided by x plus 2. Now here we have multiplication sign, so we can cancel this factor and our answer is 7x. One more question of same type. 44 in bracket x raised to 4 minus 5x cube plus 24x square is divided by 11x into x minus 8. Now each term has x and the lowest power is 2, so we can take x square common. Here we have x and we are taking x square outside the bracket, so we left with x square. Then this is minus 5x minus 24. This is 11x into x minus 8. 11 ones are 11, 11 fours are 44. Here x square upon x So x raised to 2 upon x raised to 1, that is x raised to 2 minus 1. So this division is x. Now as we have learnt in our previous topic, we are going to factorize this. But this factorization is not using identity because 24 is not a perfect square. So this factorization is by using identity x plus a into x plus b. Now as this last term is negative, our numbers will have different signs. So one number will be positive, other number will be negative. As signs are different, we are going to perform subtraction of these two numbers. So let us find out two numbers such that their product is, or a into b is minus 24 and a plus b is minus 5. Now 24 product and 5 different such two numbers are 8 and 3. Bigger will get sign of middle term. So 8 is negative and 3 is positive. So these two numbers have product minus 24 and plus 3 minus 8 is minus 5. So this is x square minus 8x plus 3x minus 24 divided by x minus 8, which is equal to x into, let us group these terms. Let us take x common from first two terms. In bracket we have x minus 8, and by taking 3 common we can write this as 3 into x minus 8 whole divided by x minus 8. We are not allowed to cancel these x minus 8 because here we have addition sign. We can cancel if there is multiplication sign. Now we can take x minus 8 common from these two terms. So here we have x and here we have plus 3, that is divided by x minus 8. Here we have multiplication, here we have multiplication, so we can cancel this exactly same term in numerator and denominator, and the answer is x into x plus 3. So by using these concepts you can solve exercise 12.3.